Okay, so the second last video for the week is going to be on the product rule. Now, the product rule of differentiation is quite simple, actually, in the fact that it's basically a rule that you need to remember how to use, and if you can remember how to use it, then you should be able to work with it quite well. So let's say that we have a function that's made up of two other functions that are being multiplied together. So let's say like x squared, lots of x plus 3 cubed, okay? We could expand this out, but it's going to be a pain in the backside to do so. So what we've got is, we've essentially got one function here, let's call it u, and we're multiplying it by another function, which we can call v. And what we can do is, when we differentiate this, is we can use what's called the product rule. Okay, so the product rule says that if we have dy dx made up, or if we have y is made up of u times v, okay, then dy dx is equal to u times the derivative of, let me rephrase that. It's v times the derivative of u with respect to x plus u times the derivative of v with respect to x, okay? So v du dx plus u to v dx, or another way to write it in our other function notation, f dash of x is equal to vu dash plus uv dash, okay? I like this one better because it's a bit easier to remember, but vu dash plus uv dash. Okay, so those are the two styles that we can write it in. So let's have a look at some examples of doing this. So differentiate each function, writing the result in its fully factored form, then state for what values of x the derivative is 0. Okay, so let's start with the first one. So we've got a. Now a says that y is equal to x squared, lots of x minus 10 all cubed. Now, what we're going to do is we're going to let u be equal to x squared, and we're going to let v be equal to x minus 10 all cubed. Okay, so then du dx is equal to 2x, and dv dx is equal to, now this is the one where we need to remember our chain rule, okay, or the shortcut for it. So the 3 comes out the front, and so does the derivative. In this case it's 1, and then it's going to be x minus 10 all squared. So now the derivative, dy dx, which is equal to du, not du, it's going to be equal to v, lots of du dx, plus u, lots of dv dx, okay? So basically what we're going to do is we're going to take what our initial v function was, and we're going to multiply it by du dx. So du dx is 2x, and our v is x minus 10 all cubed. And we're going to add that to u, which is x squared, lots of dv dx, which is 3, lots of x minus 10 all squared. Okay, so putting it together, we get dy dx is equal to 2x, lots of x minus 10 cubed, plus 3x squared, lots of x minus 10 all squared, like that. Okay. Now, we can't factorize this any further because we've got x minus 10 cubed and x minus 10 squared, okay? So we're going to leave it as it is in this form here. Now, the next part of the question says that we want to state what values of x are the zeros. So, from this point onwards, we can now work out what our zeros are going to be. So our zeros are going to be, let me just have a quick look. Sorry, that's a lie. We do want to factorize it one step further. So dy dx is equal to, so we've got x minus 10 common to both, and we've got that common to both 2 times, and that's going to leave us with then, okay, so 2x, lots of x minus 10, plus 3x squared, okay? And then from there, we can go x minus 10 all squared, and then it's going to be 2x squared minus 10 plus 3x squared, And so then we're going to get that dy dx is equal to x minus 10 all squared. And then, so 2x plus 3x squared, 2x squared plus 3x squared is 5x squared minus 10. Now, the reason why I wanted to do that is because when we're going to find the derivative, so when we're going to find the derivative of 0, we want it as factorized as fully as we can so we can work that one out, okay? So that is taking 2 of these and putting them down here, okay? Then taking this and the leftover one here and then that into there, okay? So, as I said, the reason we're doing that is so we can factorize and then find our solution when it's 0. So when dy dx is equal to 0, we get 0 is equal to x minus 10 all squared. Okay, 5x squared minus 10. So that's equal to 0 when x minus 10 all squared is equal to 0. Or 5x squared minus 10 is equal to 0. Okay? So this one on the left is equal to 0 when x is equal to 10. And this one on the right is, well, let's go 5x squared is equal to 10. So x squared is equal to 2. So x is equal to plus or minus the square root of 2. So therefore, dy dx is equal to 0 when x is equal to 10, x is equal to root 2, or /end, x is equal to negative root 2. Okay, and so that means when we're looking for it when it's equal to 0, that's just talking about when the derivative, so when the tangents of the line are equal to 0. So again, we can have a look on our equation, on our on Desmos here, we can have a look. So let's put in the initial equation. So it is y is equal to x squared, lots of x minus 10 all cubed. Okay, so we should have them at, so it's going to be flat at 10 and at, it should be root 2, so about 1.14 and negative 0.14. So if we scroll far enough out, and we go down far enough, we should get our values for when that is the case in those ones. And if we come back up, we can see that our other point where it's flat is at our 10. So it does this little whoop at our 10 there, okay? So some nice little values there for that one. Let's have a look at our second question, which is question B. So B says we've got x and we've got 3x minus 2 to the power of 6. Okay, so we're going to start off by writing down y is equal to x, lots of 3x minus 2 all to the power of 6. And we're going to say let u be equal to x. So that is du dx is equal to 1. And v is going to be equal to 3x minus 2 all to the power of 6. So dv dx is equal to, so again, that comes out the front, times it by the power that comes out the front as well, which I actually think I forgot to do. No, I didn't, because that's right, the gradient was 1, so the 3 came out. Yep, so that's fine. So 3, so the gradient of the inside comes out, the power comes down as well. Okay, then we're left with what we've got on the inside, and then 1 less in the power there. So dv dx is equal to 18 lots of 3x minus 2 to the power of 5. So back over here, if y is equal to that, then dy dx is equal to, now it's going to be, so using our product rule from before, it's going to be v lots of du dx times u lots of dv dx, okay? So v lots of du dx times u lots of dv dx. So dy over dx is equal to that. So what that means is we can start substituting some values in. So our v is, we'll start with du dx, which is just 1, and then v is 3x minus 2 to the power of 6, times u, which is x lots of 18, so that's going to be 18x, so 18x lots of 3x minus 2, to the power of 5 again. So just like that one there. Okay, so that's our dy dx, and we're going to factorize it again. So that means that dy dx is going to be, I'm going to take 5 lots of the 3x minus 2. And that's going to leave us with 3x minus 2 for this side, plus 18x for that side, okay? And then from there, we can simplify it even further to get 3x minus 5. 3 plus 18x is 21x, and then the minus 2, okay? And so that's our dy dx. Now, our next bit, we want to, just like before down here, we're going to we want to find that when dy dx is equal to 0, so when dy dx is equal to 0, okay, we get 0 is equal to 3x minus 2, all to the power of 5, and 21x minus 2. So that means it's when 3x minus 2 is equal to 0, or 21x minus 2 is equal to 0. So some bigger ones for this one, or a big value, I should say. So rearranging for x, we're going to get 3x is equal to 2, so x is equal to 2 on 3. Or we're going to get 21x is equal to 2, so x is equal to 2 on 21. And those are going to be the two values where dy dx is equal to 0. So that's it for the product rule. So only one video for this topic, which is awesome, but it's pretty easy. You're going to be mainly practicing that rule, okay, and then just using the other simple stuff to do the other way, okay? So with that being said, we're going to leave it at that, and then we're going to have a look at the quotient rule, which again is going to be another short video because it's, again, practicing just one rule. So with that being said, I'll see you guys in the next one.